Hello, everyone. Thank you for participating in today's Trident Academy session, which is meeting the challenges of POE with network infrastructure and preparing your network for future. It will be presented by Mohamed Abdel Rahman, our Senior Technical System Engineer at Trident Technology Services. I'm Maynam, Channel Sales Executive, and I'll be moderating the webinar today. The webinar will start shortly. Please, if you have any questions, submit them through the Q&A. It will be in the control panel. Mohamed will be answering all the questions by the end of the session. Now, without any further delay, I'll leave the stage to Mohamed.
All right, thanks, May, for your introduction. Hello, everyone, and welcome back to Trident Academy. The objective from today's presentation, we need to discuss and get more information about the POE and how to get more benefits out from the POE. So let's start. During today's presentation, we will cover the following topics, starting with, in brief, we will discuss some basic informations in high level of the meaning of the POE and how it works, why we need higher power for the POE++, type 3 and type 4. Briefly, will be discuss, Briefly, we'll be discuss the related POE standards, the codes, also guidance for the POE technology. The higher POE will require a high quality infrastructure, starting from the cables, the modular jacks, the batch cord. So let's discuss the impact of the performance from the higher power in the infrastructure solutions. The testing recommendations, also one of the main top topic you need to discuss, especially when you are going to design for the POE++ and the high power transmission. The POE extender, one of the bandwidth solutions, which is the lowest cost solutions to run power and data beyond 100 meters. We will discuss it also. And finish up talking about some recommendations when you are going to design the POE cabling infrastructure. So now what we need to know about the POE, as we said, we will discuss the basic informations with high level, what we need to understand about the POE. So before we start the basic informations, you have 30 seconds now. Feel free to answer the appeared questions. The powering of telecommunication devices remotely over the twisted pair cabling is a new concept started in Ethernet network POE. Is it true or false? Okay, try to answer this one before it starts the basic information. Okay. Okay, polling in progress. Okay, till the answer is appeared, let's talk about it. It's a slide. Okay, true, 65 is answered true and 35 is false. So, okay, next slide. The remote powering device is not a new concept. it is true that the remote link powering device is not a new concept. The powering of telecommunication devices over the twisted pair cable is an old as a telephone or landline telephone. It started by Alexander Graham Bell, who was a man who invented the telephone system and formed the first Bell telephony company. So the concept of the remote link power, it is not a new concept. The phone company supplies the power to the users, to the phone, with a dedicated twisted pair cabling, copper cabling, and powering the device from centralized location. So the meaning of centralized location to powering the power to the headphones, to the telephone phone. So you don't need to have any local AC power source inside, besides the telephone. So when the power is go down in your house, so the power, our phone still gets the power it needs from the phone line. So the basic information for the POE, simply the POE, it means that you can be delivering the power and data over the single twisted pair cable. So you need to enable RJ45 cable to provide you the data and the power or electrical power, DC power, to the phase, to the powered device, instead of having two separate cables, two separate contractor in your project. So we need to understand some basic or POE terminology. The POE terminology, we have two primary components for the POE, the PSE and PD. PSE, it's called power sourcing equipment. This is the source that it sends the power and data over the Ethernet cable or twisted pair cable to the powered device. The powered device, it means the load that receives the power from the PSE. Also, the PSE is divided into two types. Sometimes it's called end span. End span, example from it is Ethernet switch. The Ethernet switch itself can be provide the power to the connected device. And the second one, if you have a non-POE network switch, so you have the mid span. This is the mid span. It is positioned between the switch and phase or powered device, as shown. Okay, now for the second one, need to go closer look how the POE it's work with a high level. Starting from the POE and POE plus, sometimes it's called type 1 and the type 2 POE. You need to deliver both power and data, as we said, over the twisted pair. You have two types. For the POE or POE plus, for the type 1 and the type 2, you have two methods. Method A, which is compatible with 1 gig switch, you have to transmit the power simultaneously with the data. This is the data part or data pair. You are transmitting the power and the data over pair 1, 2, and 3, 6, which is the method. It's compatible, as we said, with most of the switches up to 1 gigabit per second. Through the simultaneously the power and data transmitted inside it. As we know that most of starting from 1 gigabit per second, you are transmitting the data over the 4 pair. So you are now getting the center tab transformer to transmit the power and data over the pair, but you are transmitting the power through 2 pairs only. One important thing need to understand or to be considered when you are talking about the POE, the power is transmitted over the data by applying something it's called common mode. Common mode, it means that the power or the current will be split between two conductors equally. So if you have to transmit the current inside the pair, you have two conductors for each pair. The current will be transmitted equally in each conductor. So you need to achieve requirements that the two conductor with the same or equal resistance. So we will discuss this point when you are talking about the testing in the upcoming slide, that if you have a mismatching or misequal for the resistance between the two conductors, you will have something called DC resistance imbalance. DC resistance imbalance will be affect your the POE and can be making any distortions for the data signal. The method B, it's called for the two pair, the power is delivered over the spare pair. For the 10 gigabit per second or 100 gigabit per second, you are transmitting the data in two pairs only, but you have two pairs for the spare. So you are transmitting now the power through the two pairs. So you don't have here center tap transformer, but it's compatible, as we said, for the switches that can support 10 or 100 gigabit per second. Starting from the POE++ or from the higher power, starting from type 3 or type 4 from the power is delivered through 4 pairs. So you are transmitting the power and the data, and also for the data, you are transmitting the data or 1 gigabit per second, you are transmitting the data over the 4 pairs. Now the power also is transmitted simultaneously through the 4 pairs with the data. You can be delivered up to, in type 4, you are transmitting from the BSCE like 99 watts, and it received at the powered device by 71 watt available to the power device. As discussed before, the DC resistance for each conductor, it is very important. We need to have balancing between each conductor. So any difference or any difference between the resistance of the conductor, it will be affect with having higher DC unresistance or DC resistance imbalance, which will be causing some error for retransmissions or bit error rate. We will discuss also during the topic for the testing this issue. Also, we need to understand that, as shown here, that more current flow when you are transmitting, as we said, starting from type 3 and type 4, you are transmitting up to now 99 watts from the BSCE to the powered device. So more current flow, it means that you have conductor, it will be got hotter. The conductor got hotter, it means that the temperature will be increased. The higher resistance for the conductor increased, which is mean insertion loss or attenuation increased, will be effect for the network performance and have a shorter cable distance. Need to understand another issue also very important here when you are talking about it, that the effect of the performance for the heat generation, it introduced in the cable bundle. So the heat generation in a single cable, when you are talking, you have only one cable running from the cabinet to the outlet, you don't have any issue, you don't have any problem, but the problem is coming from having a bundles of cable. As the most of cables, it have a maximum or temperature rating to 60 degrees. So when the cable is bundled together, as like the cable in the pathway here, that the cable will be, the heat will be increased. It will be have very significant safety issue when you are talking about the cable. So as you can see here, in the middle of the bundle, the cable in the center of the bundle, it will be heated up more than the other cables. So it have, when you have making a large bundles of the cable, the impact, it will be the heat, the temperature increasing to the cables. So we will discuss how to solve this impact or these solutions when you are talking about the infrastructure, because now the current you are having POE++, you are transmitting around 99 watt, as we said. So you need to understand the increasing of the hot on temperature inside. As shown here, the infrastructure of today is running power for many visible applications. You have now most of the applications like voice, data, lighting, wireless, security sensors, most of them need power. So by using POE++, you can be transmit now up to 100 watt over the twisted pair to deliver the power needed to the devices itself. So we need to design, we need to implement the cabling infrastructure to can be support the current situations now. So now you have 30 seconds also, feel free to answer these questions before starting the different POE available in the market now. Okay. Talking about the first device that is used to power or drive to the power over Ethernet to be eventually by IEEE. Okay. It is right, 48% for the voice over IP. This is the first device which drove the IEEE. So now, let's continue. So the applications, why we need more power now? As the polling questions, it means that the first device is called voice over IP to deliver the power to the voice over IP. As you can see here, starting from 2003, the IEEE published the new standard to transmit around 15.4 watts to support the devices like voice over IP, biometric access, static surveillance camera. But in 2009, the IEEE published the new standard. It's called for the trade market POE+, which can be transmit 30 watt and can be delivered up to 25 watt to the powered device to support more complex surveillance camera. When talking about the PTZ camera, the RFID readers, the video IP phones. In 2011, Cisco started or created non-standard POE. It's called the UPOE, which is used all 4 pair, as we said. To having the more power, you can be using the 4 pair, which is started or created by Cisco in 2011. Then it's approved in 2018. In late 2018, it's called POE++ or Type 3. To can be support to transmit 60 watts. Can be delivered 51 watt to the devices like access control, laptop, 0.11 AC. Or for the Wi-Fi 5. Finally, this one for the Type 4 POE, which can be support devices like television, video surveillance, or video conference, or Wi-Fi 6, the need for the high power for Wi-Fi 6. Also note that the list continues to grow. So this is the applications. Now we need to have the POE++, which can be support up to 71 watt, as we said, to the powered device. Okay, now what is the related standard? When you are talking about the POE, we need to understand the related standards, the related codes. So let's start talking about the codes and standard related to the POE. The first one, which is the primary standard. The primary standard for the POE, it's called IEEE 802.3, which provides a current level. It's giving you information about the current, the power classifications, the resistance, and the applications, which is guide you to the current, the level of the power. The TIA, which is a standard, the recommendations, it's talking to provide you the practices for the current, dividing to define the bundling table, how to modeling informations for the bundling for the cable. As we said, the current increased, it means that the heat or temperature increase for the cable. So we need to have a guide for the bundling of the cable, how many cable can be bundled together. And finally, the NEC, which is part National Electric Code, part of NFPA, which defines the bundling restrictions, the power limited circuit. It is mainly for the safety. It's not application for the safety and the recommendations. It is an optional recommendation you can be used. Also, another one, it's called UL. UL, as we all know, that another organizations like UL, which is investigated certificate to have when you have a higher power. Also, we will be discussed in the upcoming slide. This is the summary for the IEEE standard. As we said, we have IEEE, TIA, and NEC. So you need to review with high level the meaning and the difference between each standard and each code. The first one, as we said, the primary standard is called 802.3, which is introduced in 2003 by the meaning of POE. You are using only 2 pair, energized 2 pair to support the power, and you can be deliver up to 13 watts. You are using here 2 pair only, as we said in the first presentation, in the beginning of the presentation. The second one published in 2009, which is called POE Plus. You can be delivered up to 25 watt, but you are still transmitting over the 2 twisted pair. But the current increased now to 0.6 ampere in each pair. This current in each pair. So you have 0.6 ampere in the first pair and another 0.6 in the second pair in different directions. The POE++, it is approved in late 2018 and published early in 2019. You need to understand, starting from the type 4, you have the now type 3 and type 4, and you have energized the power through the 4 pairs. In type 4, you have around 1 ampere. It is 960 milliampere current will be transmit in each pair. So you have 4 pair, you have in each pair around 1 ampere or 960 milliampere will be transmitted or inside the cable. So one of the main impact, as we said, it is the, for this higher power or higher current, the heat generated. The heat generated when the cable is bundled together. So you need to understand and make considerations. The bundling, when you are making the bundling for the cable, and you have transmit around 1 ampere in each pair. So you have around 0.5 ampere in each conductor. So one of the recommendations from the standard and from all vendors in the market that for the higher power, starting from the POE++, to use Cat6A cable. Cat6A cable, it is give you the best thermal performance. When you are talking about the Cat6A cable, it will give you the best thermal performance. You can be support 10 gig per second, and you have optimum thermal efficiency and performance. It is very simple. As you can see here, this in this figure, it's very simple. As the higher category of the cable, the lower temperature rise. This is the meaning of the figure here. This is the Cat5E and the Cat6. For 100 meter, the temperature for the POE++ can be increased around 18 or 20 degree over the ambient temperature. But when you are using Cat6A cable, you have around 15 degree rise over the ambient temperature for the 100 meter. So the recommendations from the TIA, from the ISO, to using Cat6A cable, and extra if you have a wrap cable or wrap foiled cable between pairs to increase the thermal performance to keep the conductor cools. The main requirement to make the conductor cools, it is using Cat6A cable, and if you can be using shielded solutions or wrap foiled cable, it will be extra effect for your performance. So now you have another polling questions. You can be answer it. Feel free to answer to start discussing the TIA and 184 guidance. So based on the TIA, the recommendation when you are making the bundle for the cable, that the temperature not exceed, how many temperature will not exceed for the temperature rise within the center of the bundle of the cable. Please also don't forget to write any questions or any clarification needed in the chat box. Okay, this is the recommendations from the TIA when you are talking about the POE++ or the higher power. The recommendations that, let's see it in the next slide. Okay, as we said, the bundling is the only concern for the POE++ or the type 4 POE. It is the only main concern. The mainly impact will be happen. So the recommendations starting to using 23 AWG for the wire gauge of the cable, and also TIA in the guidance TSP 184-A, which is the standard for or guidance for the temperature rise per bundle. It is the recommendation that the temperature will not exceed 15 degrees in the center of the cable. As the maximum temperature rating for any cable, it is around 60 degrees. When you are going to the market, the standard cable or in the market cable, the temperature rating is 60 degrees. But today, another recommendations we will discuss in the following slide to get the cable with the higher temperature rating. But to have a 60 degree, which is the standard cable temperature rating, and the ambient temperatures in the cable, in the ceiling, for example, it is around 45 degrees. So 45 degrees for the ambient temperature, and the rise increasing through the POE++ 15. So you are not exceeding the temperature rating for the cable. So it is the right answer, it's 15 degrees. Also, the TSB or the TIA for the guidance, it put another several recommendations. When you are talking about the POE++ or higher power, or for the POE, for the starting or from the greenfield installations to using Cat6A cable for the higher performance from the data rate and for to improve the thermal performance for the cable. Also, we will discuss how many cables can be bundled in the following slide. Also, another guidance or another recommendations when you are talking about this one, it's called NEC. NEC, it is a National Electric Code. It is code for the safety. It's not define any current or applications. It's only for the safety. Need to highlight that for the NEC, it is an optional. It is highlighted that you don't need to do anything for the POE or POE+ or even type 3 POE++. But if the power is increased greater than 60 watts, if you have a power greater than 60 watts for the POE++, you are transmitting, as we said, around 100 watt. So you need to have optionally UL LB certificate. It is a certificate from UL. It's called LB certificate. LB certificate from UL. It will be indicate or making a test for the cable and making indication that this cable, it's tested for the POE in the worst case, and the temperature will not exceeding the temperature rating or the recommendations from the standard. So this is also recommendations. It is an optionally, you can be using it starting from the POE++ type 4 to having LP certificate. It can be mentioned here on the cable. You have LP 0.5, at least 0.5. It means that, as we said, in the type 4 POE++, you are transmitting around 1 ampere in each pair. So you have 0.5 ampere in each conductor. So in each conductor, you have 0.5 ampere. So this certificate, as we said, it is an optional, but if it is not available, the standard or code also mentions that you can be going to the MBC table. MBC table, it is included in NEC 2017. This cable, it is to define the bundling cable or bundle size restrictions to determine maximum number of cable can be supported with power greater than 60 watt. So you can be see in the left here, this is the AWG for the cable. You are using 22 up to 24 AWG. And also here you can be seeing the temperature rating. This is the operating temperature, maximum operating temperature for the cable, and number of the cable can be bundled here. So for example, you can be using this cable if you have, for example, 23 AWG, this is the cable, and you have maximum current per conductor to support the POE++ type 4.5. And you have the temperature rating 60 degrees. This is the maximum temperature operating for the cable. So now you have 81 cable maximum can be bundled without exceeding the recommendations from most of the standard. Also another, if you have, can be get 75 degree operating temperature rating for the cable, the bundle can be increased from the 91 to 192 cables. So you can be bundled up to 192 if you have cable with operating temperature 75. This is updated, happened last year also for the NEC MBC table. Minor change happened to correct the error in the original management or original measurement, but it's still the same. It's increased the digits for the temperature or the current, MC current. So you can see here, you have 2 digits after this, you have 2 digits instead of 1 digit in the old MC table. Okay, now we can be discuss the high quality. We need to have a high quality POE cable. As we said, the POE cable, it will need to have a higher quality infrastructure. As we said in the Gartner group, it's mentioned that 59 from the network problem, it's coming directly from the physical infrastructure. And as you can see here, the physical infrastructure, it is the lowest investment. It is around less than 5% from the total project capital. So you need to have a high quality infrastructure to avoid any problems maybe happen due to the physical infrastructure. So the POE required to have a high quality infrastructure cable, starting from the temperature rising. You need to understand which cable can be used. You need to understand the arcing that may be happened on the jack. The LB cable, as we said before, which is an optional certificate for the cable. You can be using 23 or 24, and so on. The DC resistance imbalance we will discuss is also, it's very important. This one, we will see the difference between 23 and 24. One of the main requirement or main recommendations when you are going to using the POE, higher POE, you need to using 23 AWG. It have a less power. You can see here the power less losses. So 23, it will be optimum. The second one, don't go to the ship cable like copper clad aluminum or copper clad steel. It is available now in the market. This cable, it is not standard cable. It's cable, it have a higher resistance. Higher resistance, it means that you have a higher temperature or high generated or heat generated. The cable is not safe to be used. Also, from most of the standard nowadays, that's a recommendation to using Cat6A cable when you are talking about the POE or the wireless access point. One of the recommendations that you can be installed from the day one Cat6A cables. So this is the history for the Cat6A cable, starting with the traditional cable. It started in 2006. It is available in the market, but after this, bandwidth making some improvement, making some innovations. As we said, the wrap cable, or it's called the matrix cable. It is every step is a way we're making some innovation, starting from the matrix cable, advanced matrix, vari matrix, and now in this year we're making vari matrix HD cable, which is the smallest Cat6A cable with diameter. It's around the same for the Cat6 cable. So it can be giving you exceptional high or alien crosstalk performance compared to the UTP cable in the market. So let's talk about the matrix cable, which is the recommendations also from the TIA and ISO to have isolations wrap constructions around the cable. This isolations wrap, as you can see here, this is the matrix tape. The matrix foil tape, it's cutting by laser, and it is optimized for the alien crosstalk. And nowadays, this cable can be supported or rated up to 75°, and also we have 90° cables. So you have flexibility to using the cable. You have the cable to support the higher temperature rating, so you don't have any concern for the bundling of the cable. Also, we have the Varimatrix cable and Varimatrix HD cable. The Varimatrix HD cable and Varimatrix cable, it is almost the same diameters for the Cat6 cable. So you don't have any concern when you're making upgrade from Cat6 to Cat6E. I'm talking regarding the conduits and busways. So you have the same sizes for the cable. Another one, connectivity and network, our next generation for the POE. Very simple. When you are plug, or when you can see here, this is the plug and this is the jack. When the plug is removed from the jack in the system, and the system is having POE signals on the cables, spark or arc will be happened briefly between the plug and the jack. So the problem it's coming from, for any cable that running POE inside it, starting from the POE, you have the spark, you have the arc, it may be happening between the plug and the jack. This spark may be making some carbon scoring. This carbon may be affect for the performance of the cable in the future. So the best way to avoid this arc working or spark, you need to turn off the POE device, the switch, before disconnect the cable from the jack, which is not impractical to making turn off for the switch, to making any disconnect for the jack. So in bandwidth, we have our jack. We're making some modifications, some design to place this point, or the place to have a spark, or the spark happening away from the point of receiving point or connections between the jack and the plug. So all bandwidth plug and plugs and jack is designed to pass this method or this test, that it ensures that when the arcing may be happen for the cable, it will not damage the critical plug and jack meeting point. This is the plug and jack meeting point. It will not affect it when you are disconnect the jack or plug from the jack. Also, it is mentioned in the data sheet, you can be support up to 25 or 200 or 2500 mating cycle. Mating cycle meaning number of connections and disconnections for the patch cord and the jack system. Another question briefly, you have 30 seconds to answer this one. Okay. So I think 41% not know about the modular plug terminated link. So briefly, you can be discuss about it. It's very important also when you are going to have POE devices. The MBTL, it's called modular plug terminated link. You are running the horizontal cable directly to the device. So you can be attached the RJ45 plug directly to the device. It is now approved and included in the TIA 568, which is recognized the MBTL. You can be having a direct connections, approved direct connections to the LED lighting, security camera, sensors, access control, so you can be using the MBTL. It is very simple. It is a two-part assembly. You can be having from the rear, it is like the jack. You can be terminated the cable directly inside it. And from the front, you can be found the plug. You can be directly plug the cable or inside the device directly. So it can be improved your security. You have a cleaner look, and the cost, it will be less expensive cost deployment for the installations and devices. Instead of using jack, surface mount box, and patch cord approach. And also, you don't have any exposed patch cord for the ceiling devices. So it's very important to talk about the MBTL when you are going to have POE devices. And now you can be connected like this picture. You can be connected directly to the device. Also, the 28 EWG, as you can see here, the 28 EWG, it is very simple. It is a smaller size from the patch cord. This smaller size, as you can see, this is the 28 EWG. And this is a traditional one for the patch cord. It is 24 EWG. The 28 EWG, it can giving you more better port visibility. You can having easier management. You can be bundling the cable easily inside the cabinet. You can be having airflow management inside the cabinet. So you have, as you can see here, you can have a space for your finger to making connections and disconnections for the plug. This is the difference between 28 EWG and 24 EWG from the sizing perspective. So now you have another polling questions can be answered. It's the maximum length or maximum channel length can be supported when you are going to using 28 EWG. Okay. 100 meter, it is 45%, and 18 asked for 96. Okay. Due to the smaller size for the patch cord, you have a limitation for the distance. The distance, it's not 100 meter. 100 meter when you are using horizontal cable, 90 meter, and you have flexibility to have 10 meters for the patch cord, but when you have a 24 EWG. But when you are going to the 28 EWG, you have something called derating factor. Derating factor, you must be considered. So you have two examples here. You can be used. You can be using 80 meter or 90 meter for the horizontal cable from the solid cable, and you have 6 meter for the patch cord. The patch cord distance, it decreases due to the smaller size for the conductor, due to the attenuations maybe happen for the 28 EWG, so the making some derating for the channel. Also, if you need to have maintain the length for the patch cord to 10 meter, you can be decreasing the channel to 82.5 meters for the permanent length. Also, you can be going to the applications. We have applications on the mobile for Android and iOS. You can be checking for the derate it. It's called derate it. You can be checking the maximum length can be used if you have a 24 EWG or 26 EWG or even 28 EWG patch cord. 28 EWG patch cord also can be support POE++, but you need to consider that this cable with a smaller size from the conductor, this cable can be heated more than 23 EWG. So the recommendations when you are making bundling for this cable, the maximum bundle can be, cables or patch cord can be bundled 24. So it is also the recommendations in the TSP, TIA have another guidance. It's called -A-1, which is related to the POE impact when you are going to using 28 EWG batch cord. Also, very brief with high level information also about the testing of the POE systems. You can see here, one of confusion maybe happen, the difference between the DC resistance loop or DC loop resistance and the DC loop resistance imbalance. You have two different scenarios when you are talking about the DC loop resistance or DC loop resistance or resistance imbalance. The DC resistance imbalance within the pair, as you can see here, this is the resistance for the conductor and the resistance for the conductor. The difference between the two resistance, it's called resistance imbalance. We need to have identical resistance for the two conductor. So the difference between them, it's called DC resistance imbalance. Also, when you are going to talk about the POE++, it's also added to the recommendations that you need to know the DC resistance imbalance between the pairs or pair to pair. You need to measure the difference resistance between the two conductor in the pair and the two conductor in another pair. For example, we need to get the difference. You need to get the total resistance for pair 1,2 and pair 3,6, for example. Then the difference between them, 0.11. You have a limitations, 0.2. This is the maximum limitations from the standard to can be support the POE++ or higher power inside the cable. It is one of the recommendations to going to perform this test, the DC resistance within the pair and DC resistance pair to pair. As you can see here, this is a snapshot from Fluke DSX 5000. Also, as you can see here, the DC resistance imbalance between pair 1 and 2, this is the pair 1 and 2. DC resistance imbalance, you don't have any matching between the two conductor resistance, so it will have a fail. This test, historically, it made it factory, but now it can be tested in your field. Also, this is the pair-to-pair imbalance resistance. You can be measure it to get your system pass and can be support and don't have any issue for the data transmissions and the power to the device. Also, we have like 2 or 3 minutes. Quickly, we can be talking about our solutions. It's called POE extender. The POE extender from the bandwidth, we are talking about the low devices, the low data rate, and low power. Sometimes the distance is greater than 100 meters, beyond the 100 meters. In your infrastructure or in your commercial building, the distance increased greater than 100. For example, you have 200 meters for the emergency telephone, for the camera. So we need to have a solutions to solve this problem instead of using the traditional solutions. So you have now polling questions. Feel free to answer this one. Okay. Okay, most of the people are using the extender, POE extender every 100 meters. You are using multiple of extender to extend or repeater to extend. Many of them talking about the fiber and media converter from the post side. So let's have, this is the solutions you have mentioned in the polling questions. This is the solutions available in the market. You can be using multiple IDFs. You can be, which you can be placed switch closer the endpoint. The second one using the fiber and media converter from both sides, but need to understand and make intentions that you need to have here mandatory power supply for the power for the media converter. You need to have the power supply to connect the media converter and to convert the fiber to the copper again and to inject the power to the device. The third one, it's called the hybrid fiber. It's available in the market, but it's very complex to having the power inside the fiber cable. Hybrid fiber need technicians have expert in the power and fiber. But in bandwidth, we have POE extender. POE extender, it is like a kit for the transmitter and receiver. It can be available 1-to-1 or 1-to-4. It can be extend the distance up to 610 meters. So you have 2,000 feet between the transmitter and the receivers, between the transmitter of the kit and the receiver of the kit. You can be used, and also one of the main thing you need to understand, you need to put in your consideration that the data rate for it 100 megabit per second. So it is suitable for the low data rate like surveillance camera, emergency telephone, RFID. You can be using the POE extender, and also it can be support up to 70 degrees. Let me show you the multiple scenario. As we said, we have 1-to-1. You have one transmitter and one receiver. We have one transmitter and 4 receiver. And also you can see here, you have many multiple scenarios. We can be discussed offline, the scenarios available, but you can be using POE switch. When you are using the POE switch, the transmitter and the receiver, you don't need to have a mandatory power. It is an optional power. And also, sometimes you don't have a POE switch, so you can be inject the power to the transmitter. Here, you can be using the power supply of the transmitter and inject the power inside it, and you don't need to have a power source to the receiver. Also, this extender can be extended for IP devices. These 4 IP devices can be used and using only one cable running to the switch. So this is also another application you can be used. Also, another recommendations now, when you are going to using a transmitter or the POE extender or transmitter beside the switch, the recommendation from us, it is a new product. We have now transmission panel or POE extension panel. It can be support up to 8 POE extender transmitter and can be mounted on the rack. And using smaller batch cord, you can be connected to the legacy of or old non-POE switch. So finally, you have 2 minutes only now talking about the recommendations. So what is the recommendations for the increasing of the high power? Need to have need additional precautions when you are talking about the cabling installations and to avoid the overheating. You have 3 considerations when you are going to the POE. The first one, the cable wire gauge. As we said, starting from 23 AWG, it will be suitable when you are talking about the POE. You need to consider another factor, the temperature rating. You need to choose a cable with higher temperature rating. Also, as per recommendations, the Cat6A cable, and if you can have a wrapped cable or wrapped foil for the cable, it will be good to using in your solutions, like matrix cable. Also, you need to follow the TIA and the ISO recommendations that the maximum bundles of the cable to be 24 cables or less, to having to limit the heat generations by the current. So to limit this one, you need to have small bundles, 24 or less of 24, when you are talking about type 3 and type 4 POE. Also, another recommendation, you need to select the solutions or the components that can be supported the POE++ or POE+ by using the cable, avoid any arcing effect or having the test. As we said, we have test, it's called 99-001, which is related to the arcing problem. So you need to have this test and have higher mating cycle for your cable. Final recommendations when you are going to the POE devices, if you have a ceiling devices, or you are talking about the LED lighting or security cam or sensor, to have a direct connection to using the MBTL connections to connect the device directly through it. So now this is the solutions from the bandwidth. As we said, we have our matrix cable. We have our matrix cable. It can be support to 75 degree or even 90 degree. So you don't have any concern for the bundling size for the cable. Also, most of the modules or direct connections or even batch core, it is rated to 2500 meeting cycle. And also you can be using 28 AWG batch core when you are talking and MBTL. And finally, we have the lowest cost to run the power and data beyond 100 meter by using the POE extender. You can be support distance, or you can be having distance between the transmitter and the receiver up to 610 meter or 2000 feet between the transmitter and the receiver. Also, you can be using these direct connections from both sides here and to connect directly between the both of sides. And also it is approved to use it and making the test it using your tester. Thank you for your time. And if you have any questions, feel free to ask and put it in the chat box.
Thank you, Mohamed, for the very informative session. Please, before we start the question, I'd like to point out that at the end of the webinar, a survey will pop up on your screen to collect your feedback on today's session. So please, your input is highly appreciated, as we're always looking to optimize our work to fit your expectations. And now we will back to Mohamed to answer any questions in the chat.
Okay, I think we have two questions here related to or regarding to the POE. Can have the first one. It's called, can we using which category can be used for the POE extender? As we said, the POE extender, it's compatible with any standard 4-pair cables starting from the Cat5e. You can be used, but the recommendations from our side to using Cat6 cable. 23 AWG, as we said, 23 AWG, it having a power loss, minimum power loss for the cable. So this is the recommendation. Another one can be used it in outdoor application. Yes, it can be used in outdoor. As we said, it is really rated to 70 degrees. So you can be used it in outdoor application, but make in your attention or consideration to having like outdoor enclosure. So outdoor enclosure to putting it inside, to put the POE extender or the receiver inside it. Also for the 1 to 4, the 4-port receiver, another question, it is called that the 4-port receiver, it is like a switch. Yes, the 4-port receiver, when you have a 1 to 4, it is, behave like a switch. You can be, it is an intelligent, it can be aggregate and sharing all data and power, and can be transmitted through only one cable upstream to your switch. Also another one, the final one, what are the warranties for this system provided to the end user? As we said, most of or all devices from bandwidth can be supported for 1 year up to 18 months for the warranty or for the product, our product warranty from any defections. And also if you have end-to-end solutions, you can have a warranty for 25 years. Okay, thank you. And I think what will be the matrix maximum length between the old receiver and the end device? I think you are talking about the distance between the transmitter and the receiver. If you have a POE switch, so you can be putting the transmitter 15 meters between the transmitter and the switch, another 15 meters between the receiver and the powered device, and you have around 600 meters. And also it depends on the power needed. So you can have calculations, you need to understand the length and the power needed and the power class for the powered device. Okay, I think no questions also again. So no questions also. Thanks.
Thank you, Mohamed. I hope you all enjoyed Mohamed's presentation, and it has expanded your knowledge to the latest POE technology and trends, as well as the challenges of POE with the network infrastructures and its impact on cabling performance. Please, if you have any questions on this presentation, you can contact Mohamed via his email address shown on slide. It's now showing. It's mohamed.abdelrahman@itrident.com, or you can send us directly at info@trident.com. Once again, thank you all for attending today's session, and we're looking forward to see you in the upcoming Trident Academy session. Thank you very much.